Hey Algebra students, today for lesson 4 we're solving and graphing compound inequalities and also write verbal sentences as a compound inequality. Those are the two I can statements that we are covering. You can see here that this one has a multiplier of 3, so that's going to be a major thing for you to be able to do for your exam. Okay, first of all, what is a compound inequality? It's one of those vocabulary terms I used to get intimidated by because I didn't quite understand it, but basically all it means is you have more than one inequality. Okay, we've seen these before in the year when we did domain and it was in between two numbers. We might see something like this, where basically it means x is greater than or equal to 5, but it's less than or equal to 7. It essentially meant that if you had 5 and 7, it was everything in between it. Okay? So we actually have two types of compound inequalities. The one that we just showed you would be considered an AND inequality, where it's everything in between. Okay? The other type is considered an OR inequality. It's less than this or it's greater than that. So maybe it looks something like this: x is less than 5 or x is greater than or equal to 7, in which case they're going to split apart instead of coming together. Okay? So we might have something like this, and 7 greater than 7, something like that. So keywords that you need to look out for, and for compound inequalities, will be everything in between, or will split them apart. The little trick that I've come up with to remember is OR is kind of like divorce, and when you get divorced you separate. So if you don't like it, come up with your own. Alright, example 1. Okay. All real numbers are less than -1 or greater than 2. Okay? So if we put these in inequality form, we'd say x is less than -1 or x is greater than 2. Right, so on our number line, we need to make sure that both these things are on here. I think we can safely go by ones. And we have -1, less than that, and then +2, and greater than that. And there we have our first compound inequality. Now here, this one, it can look intimidating, but it doesn't have to be. Okay? If you realize that all I have to do is split it up and make truly just two inequalities. So I have 1 is less than -2x plus 3, and I also have -2x plus 3 is less than 19, and then I just have to solve each one of these and graph them. Well, it's no more difficult than what we did the other day with multi-step inequalities. I'm going to subtract 3 from both sides, and I've got -2 less than -2x. Again, here with all the steps, sometimes students forget little things that they knew earlier, like if I divide both sides by a negative number, I have to switch the sign, and then also if I want the x on the left, I would have to switch the sign to go along with it. So I have x is less than 1, and well, now we need to solve the second one. So I subtract 3 from both sides. Now I've got -2x is less than 16, and then divide both sides by -2, and x, again now I have to switch the sign because I divided by a negative, greater than -8. So these are the two things, and I have to graph both of them, and of course these should come together. This is an example of an and inequality where I've got, x is in between two things. So let's see, maybe we'll go by 2's here. 2, 4, 6, negative 8, and 2, 4, 6, positive 8. I want x is greater than 8, so it goes this way. But then I want x is less than 1, 1 being here between 0 and 2. And it's less than this, and they meet in the middle. All right, well, there it is. We have solved this compound inequality, and we have also graphed it. All right. Looks like we have one more here for lesson 4. This is an example of an or inequality, and we have or divorce. We're going to separate. The two lines should go away from each other, but the principle is still the same as the last one. We're going to just solve both of them. So here I'm going to add 2 to both sides. I have 3x is less than negative 9. Divide both sides by 3, and I have x is less than negative 3. I did not switch the sign. I was dividing by positive. Right. And then on the other side, we have subtracting 8 from both sides, so 2x is greater than 8. Divide both sides by 2, and x is greater than 4. Okay. So I think we go by ones safely here. 1, 2, 3, 4. And 1, 2, 3, negative 4. We want x is less than 3, so it's going in that direction, but x is greater than 4, meaning it goes off in this direction. And they separate just like we supposed that they should. All right, that's compound inequalities. Not as bad as you might have thought.